Okay, guys. Okay, let's get started. Yeah. Okay, we have been talking about the Docker related stuff, and this is the first class for the Docker. And let's go to our curriculum, which we have talked about here. And we completed the AWS part, which we have learned, and we have learned about the the Linux source code management tool, CI/CD, right? I know Artifactory management, which is a JFrog, is pending. It is just only 1 hour class. I was intentionally waiting to complete the basic part till the Docker. Okay, once we have completed the Docker, we will be talking about the JFrog, and then we will be talking about the one use case which composes all the tools, including from the you know GitHub, Linux, CI/CD, the Docker, then JFrog. I mean, we will be talking about those. I mean, why, as if you remembered in the first class itself, we have mentioned that the shuffling would be there, especially, but not everything. There is an order that we have to know about it. Okay, so we do follow the same thing here. Okay, now let's come to our part here. Now, let's talk about the Docker now. Why? Because this is one of the container technologies. And Docker, I mean, if you ask me, there are some other alternatives like other tools, like Jenkins has a Team City or Traverse CI, right? Similarly, Docker also will have an alternative. So those are the LXD. There are some other tools. What is that? Mesosphere. Okay, Docker alternatives. Yeah. These are the some of the things. Podman, Runc, LXC, Vagrant. So, I mean, of course, these are not all the alternatives exactly for Docker. Okay, but underneath the Docker, there are some other things which has been present, which has been common for all these tools. For example, there is a Jenkins server. In order to run a Jenkins server, you require a Java, right? Java is the base one. Without Java, you can't run the Jenkins server because it is built on the Java only. In a similar fashion, either Docker, Runc, or Podman, or these tools also will be work on something called LXD. LXD is the underneath which was being developed under the under the Docker. We will talk that as well here. Okay. First thing is, where is this? Let's talk about the some brief history about the Docker. As we just mentioned, these are the some of the alternatives for the Docker, but we want to talk about the how it works, and there is some differences that we should know why this Docker is exists. How, when you compare with the VM, how do we got those things that we will be knowing about that as well. Okay, see, the main thing is every tool exists with a one solution, meaning if there is a tool, there is a problem, and if there is a problem, there is a solution. That solution is nothing but the tool itself here. Okay, so the point here is before before containers or before Docker comes into picture, we were been using a virtual box, or VMware. Okay, this is the solution and everything. Everything is for the shippable purpose, meaning generally, if there is any web application or if any application, how do we do is for every application, we will have a one server will be allocated. Okay, for example, you have a web server, there is a one server you would be installing it. If there is a database server, you would be installing a separate server for that. There is an email server you are maintaining, you would be using another server. If you have any DNS server, of course, most don't. They don't use the DNS server because more. I mean, if you are working in some other heavily depending on the DNS server. I mean, not all the companies would maintain the DNS server because it doesn't require. Okay, so like that, every server, I mean, for every application, they required a one or few more servers itself. That's why, what you need to do is, if you have a 5 or 6 applications or 5 or 6 components in your entire web application or in your software, you required ending up creating a 5 or 6 servers for that. So like that, it will be very, I mean, say, time taken, and as well as the cost effective also here. Okay, so generally nowadays what we are doing is, this is a server and this is a web application, this is a database, and if we have any cache database, if we have any key value pair, any of the other sets, if we have any queue service, what we have been doing is, we are trying to accommodate all these servers in the same mission itself. I mean, all these applications or components in the same, within a single server itself. So what you need to do is, one more thing is, if your web application is running on a Windows, and your database is running on a Linux, and your cache database is running on Windows again, and your queue server is running on a Mac, so you have a dependency of a different OSs. For example, your dev environment or your production environment exactly required these many requirements, right? Similarly, customer is also required to provision same same environment in their on premises or in their environment. Okay, it's exactly look the same thing. So what, I mean, it's completely depending on this. If you do some changes in your dev environment, you have to do the same thing in the customer environment. Again, it will be burden to the customer as well as the development team also. I mean, whoever has been delivering the software. So in order to avoid that, what they have done is, they have, what do you say? They have minimized all the efforts by isolating all the environments itself. What they are saying is, irrespective of your server is located, for example, as we mentioned here, DevOps is, the Docker is, so this web server is required a Windows, and this database server is a Linux. This Redis database server. This is a SQL database service is required another Linux, and Q server required a Mac, right? What they are doing is, hey, customer, what I'm going to do is, I'm going to give a container. That container will work in any of the environments. So you don't need to maintain all these. For example, this required a Windows, this required a Linux, this required a Mac, right? So we don't remove, I don't say you have to run this container only in Windows, you have to run this one in only in Mac, right? I won't give us such kind of restrictions. I'll just give a containers, you can just run in your environment. That environment could be anything, OS independent platform. You can't depending on any of the platform of OS. So what they are doing is, they are shipping, they are putting inside, for example, they are putting a application or web server inside a container, and then they are shipping a container. So once the customer got created an environment, for example, he has a server that is only the Windows, what they do is, they'll import this as a container instead of deploying as a web server. Same thing will apply for the Redis cache, which is for the in memory. they'll be deploying as a they'll be deploying as a container. Same thing here also, they have been deploying the database server as a container, which contains inside a database here. So this all, earlier everything was being independent and it required its own platform. It is a depending on their own platform. Now since we ship as a container is nothing but a Docker. Here we are talking, I'll just give a we'll talk about in detail exactly what exactly the container. For the basic understanding, just remember we are talking about the container, which is different from image also. We will talking about that as well here. Just for Docker introduction, we are talking about all this because this is one of the use case. Okay, so we are shipping as a Docker container or image here itself, and then this would eliminate the platform dependency also. Okay, this is a one problem. I mean, this is a one solution, or this is a one advantage of it. Next advantage is that, let's talk about this one. So currently, you can say that, sir, we do have a virtual machines, right? What is the problem with the virtual machines? I'll tell you. Same thing, whatever you have done, right? What you have done is, you, I mean, with the same use case, instead of putting this web server, this database server, this cache database server, everything inside a container, you can create a virtual box, meaning however we are doing, right? This is a one virtual box. You can directly click and export to this, right? You can directly, I mean, you can say that, sir, we can export and then ship that as a OVA file instead of a container. Yes, you can do that, but there is a disadvantage. I mean, there is a more advantages when we ship as a container versus when we ship as a OVA. Let's I'll tell you why and how. So before going that why and how, first let's understand how our virtual box works here. I mean, this is let me show you here itself. Instead of me drawing it here, right? Okay, so okay, this is the simple one. Yeah, this is the best way. The infrastructure is either on premise or cloud or database or data center. Sorry, these are the three, irrespective of any of the platform that you do have. What you will be having is, you will be having a base OS. For example, I have my laptop, this is my infrastructure. Okay, under the infrastructure of my component, I do have a first OS in it. That OS is nothing but a Windows OS or Mac OS or Linux OS. And after having a OS, once we install, I mean, if we want to work with the virtual box or VMware, right, what we should be doing is, we should have a hypervisor in it. Hypervisor is the one of the tool which will be an intermediary between virtual box and your OS. Okay, let me tell you an example. We have a kernel, right? I mean, a kernel, right? Kernel is an intermediary between the OS and our hardware. Hardware is nothing but our laptop. In a similar fashion, hypervisor is an intermediary tool in between VirtualBox and our OS itself. What will tell you, what this hypervisor will do is, to the infrastructure, hey, I'm going to enable virtualization, meaning, I mean, I'm going to enable the virtualization, or I'm going to use the features of the virtualization. Please allow me to do that. What does it intend, what does it meaning is, it is mimicking the, it is having a more hardware. I'm just dividing this hardware into multiple parts. This is what hypervisor is doing it, or telling to OS. Simply it is telling, hey, I'm going to create another OS along with the base OS. Please allow me to do that. So that's what hypervisor is telling to your OS. Okay. After I mean, this you don't need to install separately. Whenever you install a virtual box or VMware, it will automatically install the hypervisor in it within itself. Okay. So you don't need to specifically. But the thing is, you have to understand, if you have installed the virtual box or VMware, it will internally have the hypervisor in it. That hypervisor itself is one of the tool which will act intermediary between the virtual box and your OS itself. In order to work this hypervisor, what you need to do is, you have to enable the one of the feature called virtualization in your laptop. That you have to do it by your settings. Okay, I'll just show you BIOS settings virtualization. In the boot menu, you have to enable virtualization here. If you see here, there is something called virtualization. If you are working in a Windows machine, what you do is, mm, Just a minute. Okay. So if you want to enable this virtualization in your laptop, you have to enable some settings in your BIOS. So meaning, I'll just show you. For example, I'm going to create this, right? And for example, I'm giving here. And if you see here, we are seeing a 32-bit, 64-bit, right? If virtualization is not enabled, you can't able to create the 64-bit version of the OS. That is only the finding out that you need to. If I mean, for example, when you are creating a virtual box, right? If you select the 64-bit of Windows 7 or 64-bit of Linux, right? What you would be doing is it won't allow you to go for the next step because the virtualization is not enabled. So that is only the point that you can find out. Your laptop does not have a enable the virtualization. So for that, you just need to enable the virtualization in your BIOS settings of Windows machine. Okay. So I mean, of course, it would the same for the Linux also, but this is the one thing. And why we are talking about, yeah, in order to work for the hypervisor properly, we should be enabling the virtualization settings in our BIOS settings of our laptop. Okay, now this is the one thing. After that, we will be creating a one virtual box here, the one which I'm showing here, right? Guest OS, bins, lib, all this, right? This is a one virtual box, this is another virtual box, this is another virtual box. Totally we do have a three virtual box here. Okay, let's see in which virtual box is nothing but the app server which we just talked here. Okay, for example, this is a one virtual box. Let's take this is a virtual box of a web server. This is another virtual box of a Redis cache database. This is another virtual server for the SQL database. This is another virtual server for the queue service. Okay, similarly, like this, we do have a multiple virtuals. The problem with this is there is a duplication of the OSs here. Guest OS is nothing but the virtual box here. The base OS means the base OS or host OS, we'll call it as a the provider who is uh, for example, in my laptop, my base OS or my host OS is a Windows. Okay, in the virtual box here, this is a guest OS of Ubuntu 1. This is another guest OS of Ubuntu. So this is what it is representing, a guest OS. Yeah. Okay. For this, what is happening is, since even though application on top of this, we are running our applications. It could be database server, web server, queue server, or cache server, in memory of anything. Okay. So there is a common point between the all these three things. That is nothing but a duplication. The duplication is nothing but the OSs. Even though all three virtual boxes having a are using a same OS or different OSs, it is ultimately using the base OS resources only. Okay, meaning it is a duplication of having a multiple OSs. So to avoid that, how the Docker has come into picture is, I mean, to avoid that kind of situation, Docker has implemented another way of dealing the base OS. What it is showing is, having instead of having its own OS like these guys, what it is doing is it is internally depending on the base OS itself. Okay, here it is. Operating system is the base OS. Let me tell you an example here. In my system, I mean, in my OS, I mean, this is an example, right? In my Windows machine, instead of having, if I install the Docker, right, instead of having a separate Linux OS, it is sharing the OS related resources from my base OS, meaning from my Windows OS. Like this, we can have multiple Docker things or Docker containers or Docker images sharing the infrastructure or resources from the base OS itself or host OS itself. So this way, it will allocate, or it will eliminate the the having a multiple OSs, which is a duplicate. This is why we can't able to use the virtual box. Of course, people are using a virtual box for shipping the things also here. This is the second point. Okay. Now, let's talk about few more things also here. That is nothing but the a small part of this one. Um, since we talked about here, right? It will also have a modules like, meaning our base OS has a, our base OS means if you install any OS, it has a, some functionalities related to volumes, disk management, file system, okay, uh, networking, registries, everything will be same. It won't, you can't say Docker is having a minimal capability of OS. Docker is Docker will share the base OS resources and use that as a their own OS. That is only the main difference here. Okay. It's one more thing is, which is basically, 1 minute, guys. Okay. Docker has written basically in a Go language. Okay. Docker technology has been developed using a Go language here. Okay. Initially, the Docker name is Docker 9, and later on, it has been converted into the Docker. Okay. And one more thing is, underneath of the Docker, there is a tool called LXC. LXC is the base part of it. Okay. Here, here. See, if you see here we are talking as a LXC here, right? LXC is also another library. On top of this, container is being presented. If you take Mesos OS, you would replace the Docker, but internally the Mesos also LXC is being used. If you take Podman is another container tool. Under the container tool, LXC is the basic one. So ultimately, LXC is the main application in order to work with the container tools. Yeah. Okay. And now let's start about installing the Docker here itself. Any questions, guys? Now let me bring up my mission here. Please let me know if you have any questions. Guys, you have to ask me the questions. Um, this one related, because this required. You will get to know. I'll tell you. The If you are attending an interview, let me put it this way: interview oriented, right? So if you put your Docker in your resume, they will definitely ask, why can't we move to the virtual box? What exactly? Why do we need Docker instead of virtual box? What exactly the main purpose of the Docker? There are two things. One is easily shippable and manageable. Another one is independent of the platform here also. Okay. There are a couple of other things also. People would expect what you can do is you can do a research of whatever I've discussed, right? Apart from that, you guys also start researching something about why we should use a Docker. Put a WHY questions. 4W and 1H questions, right? You do the some research, because if you put your resume, Docker in resume, you can expect a lot of questions from the Docker, because everywhere Docker is been main thing. Of course, Docker was underneath. Even people are moving to the Kubernetes, but underneath the Kubernetes, Docker is the main thing. Okay. So you have to do some research and then get hands on. So please try something. Okay. Okay. Now let's install the Docker itself here. So first we should have, now let me log into SSH. Four. Okay. Yeah, I'm done here. So I'm just updating it here. So the next one is I'm just following the digital version documentation. This is a pretty much a good thing also here. Okay. Okay. So the next thing is once this is done, let's add the certificate here. Now let me add this GPG keys here. Okay. Add the repositories here. Now this is the Docker C. Guys, all these steps are like, if you see here, there are something called Docker BuildX plugin, BuildX Docker Compose, libc, and a lot of other tools has been installing here. So all these steps is nothing but you are just updating this, and then you are installing the prerequisite softwares, which is transport, https, ca certificates, curl. Okay, all these related certificates, and next you are adding the Docker repository key to your repositories list, and then you are mentioning the Docker under the your file, and then you are checking whether whatever you have added is being everything is working fine. It is saying that underneath you have this version is available based on your OS. So you just install apt get install docker c would work for you. So this is what it has been now. Now let's check the system docker here. Okay, it has been failed. For what reason? Okay, it is saying failed to start the docker service. Now let's stop the docker. Now let's start the docker here. If you want to see if there is any error, it is suggesting here, please use this docker service. Okay, it is failed to do this. So why? Failed to start the docker application container engine. Okay. Okay, there is a problem, guys. So it has been clearly saying this is requests are going frequently here. So you just can find a reason why this has been doing, because of some of the things that we have tried here. Okay. I really don't know what's going on, but I ran this and looked at variants, reboot my PC, Docker works perfectly. But still, okay, debug information, you have done a Docker daemon differentiating. Okay, maybe let's check if there is. We do have a workspace here. This is not problem for us. Okay, these guys are clearly saying this is the problem. But still, let's check this, whether do we have this or not. Yeah, it does not have. Okay, let's enable the debug modes. Yeah, this is running fine then. Let's see if there are any errors here. Info. Yeah, 153. Yeah, here is something. Yes. So this constant namespace error, RPC error. Okay. Okay. This is the command. It is started, and what we do is we just reboot. Now we'll see if there is something that makes a difference here. We just reboot the mission. Meanwhile, let's understand one thing called Docker architecture. Okay. Okay, here. Here, if you see a couple of things. This is the right, but fine, all are fine here. So if you see here, the client and Docker host in our use case, both are same. Not in our case. Most of the time, both are in the same thing. Let me tell you. Whenever you how do find which one is a client and which one is a server? Basically, client means a Docker command. Whenever you see a Docker command, which is a client. Okay, for example, you are opening a web server and you are trying to access the Facebook server. How do you access the Facebook server? You open a Firefox. That Firefox is nothing but a client. You are using a client which is nothing but a Firefox and then accessing a Facebook server. Similarly, you are accessing a Docker related commands with the command called or client called Docker command. Okay, whenever you use a command called Docker D, that is nothing but the Docker daemon, which is nothing but the as Docker server. Okay, that's Docker server could be your local machine or your remote machine. Meaning, by using a Docker CLI command, you can connect to the a Docker daemon, which is in another mission, which is nothing but a remote mission. Like you are connecting to the remote mission using a putty, right? Putty is a client for SSH. Similarly, Docker command is a client which you can connect to the remote mission. That remote mission could be your local mission or it is in somewhere else. We will show you also here. So ultimately, what I want to say is, whenever you install a Docker in your system, you would have two things. One is a Docker client, another one is a Docker host. Okay, Docker daemon. This is another component. Third component is a registry. Registry is nothing but a storage place where it can store the Docker related images into the registry. Registry is nothing but a place where it will maintain the inventory of the images, like what images has been, what Docker images has been pulled, what is not been deleted, what is running, and everything, right? So these are the maintaining registry related to the Docker images. These are the three main components will be present under your when you install a Docker command. Docker here. Okay. Now let's see how these three would be communicating here. Okay. Whenever you do, there are some commands like Docker build, Docker pull, Docker run, Docker D, Docker restart, Docker Docker create, Docker service, Docker logs. There are a lot of commands here. Okay. So for example, let's take a basic operation called Docker build. That is also another advanced one. Let's take an example of Docker pull. What does it mean is, pull means get something, right? Or get something. Okay. So whenever you do Docker space pull command, what will happen is, first, it will tell to the Docker daemon. Docker daemon meaning which is a Docker service. Daemon is nothing but a one program which will keep on running forever till the system shutdowns, meaning it will run on the background mode. Okay, a daemons, we'll call it as a daemons or workers. Okay, or services, these are all the same. All the services will be running in a background here. Okay, whenever you do whenever you just Docker command, first it will talk to the Docker D, which is nothing but a server. And then, for example, next one is whatever the command that you have given, pull of what? You would be providing a Docker D also here. Let me put here something here. For example, this is a command, image name. You are telling, I want an image related to the Ubuntu. I'll talk about the image or what is image and all the stuff here. What does it mean is, first it will talk to the Docker host saying that, hey, I want to pull Ubuntu image. Then it will say that, okay, first it will go and fetch its local repository or local registry of which has been hosted, which you have installed here. Then it will find if there is any image called Ubuntu, it will just show you the result. That's it. If it did not found any of the images in their own repository or in their own registry, it will go to the remote registry. That registry is nothing but a Docker hub, and then go to there and then search for the Ubuntu image and then get that in their own local registry first. So this is how the communication will happen from the client to Docker daemon, from Docker daemon to the registry. If you use some other command like Docker run, right? The Docker run will tell you your something like Docker run Ubuntu. If you give something like, please run this image, it will tell you, right? You are saying from client, from the client, you are saying Docker run Ubuntu. First, we'll go to the Docker daemon and saying that I want to run Ubuntu image. Then again, it will go to the local registry and then find are there any Ubuntu images. If not, it will go to the remote registry and then download it. If it present, it will just run it in there itself. Okay, so this is how the communication will be happening between the client and Docker server in the same host. Okay, I hope this helps you understanding how the Docker works internally. Now let's see. Or not four. Okay, Docker is running fine. Let's see Docker here. And it will tell you Docker is working fine. These are the things that you can try with the Docker commands like run exec, ps, build, full, push, images, login, logout, search. Okay, some of the management, like if you are talking with the Docker server, right? If you want to change something, you can use these some of the management command which is related to the admin. And the next one is a Swarm. Swarm is another part of it, which is like the now you are, if you are dealing with a few images, you are fine. You can directly use the thing. But if you are managing multiple containers or multiple images, like more than 10 or 20 or 100, right? You can use a Swarm. Swarm is nothing but an orchestration tool which will manage with the multiple containers. For example, in your office, if the employees are more than 10 people, it's a difficult to manage for one CEO or one CTO, right? That's why they would hire another HR to deal with all the employees, especially the office related and all the stuff. Similarly, if you are maintaining a multiple containers which has more than 10 or 20 or 100, right, you would be using a Docker Swarm, which is will be coming along with the Docker installation only. Okay, so these are the some of the commands that you would be finding here. The main thing is you have to know when we are learning about the Docker is especially how to create a Docker image, how to build a Docker image, how to run it, how to debug it, how to maintain the logs, how to Dockerize your application. So these are the main things that you need to be focused here. Okay. So, but irrespective of it, whatever we mentioned, we'll deal with that along with whatever I just mentioned, because that is being required when you join a company here. Okay. Okay. Now we just installed and then configured the Docker in itself here. Now let's talk about something called images here. The main difference is image is nothing but a combination of layers. That layer is having a application. Application could be a OS or your web application also here. Let me put it this way. For example, we talked about the images, right? Let me put this. I'm looking for one image. Okay, here. For example, I have taken you Ubuntu image. Let's see how that image looks like here. Okay. For example, this is the Ubuntu 20.04 image, and that contains this information. All the information. Let me pull and see you instead of directly being showing you. Docker pull image. Image name is Ubuntu. See, when you don't mention something called things, right? It is pulling the Ubuntu image from somewhere else. I mean, from the Docker Hub repository. That is what it is showing you here. Docker images. It is clearly saying there is a image called Ubuntu, which was created 3 weeks ago, and the size of this Docker image is 77 MB, and which is the tag called latest. What exactly this is called? I mean, you have to specify which version of Ubuntu you want. You want 20.04 or 22.04 or 18. You have to mention this. This is nothing but a tag. Okay. If you don't mention anything, by default, it will append latest. Latest is nothing but whatever is the latest they have put in the Docker Hub, just give me that. Okay. So what does it just happen is whenever I just pull called Docker pull Ubuntu, first it went to the my local repository, my local registry of the Docker, and then search for Ubuntu image. It found it did not found in my local machine, so it went and downloaded that from the remote, I mean from the Docker Hub. Docker Hub is the place where you can find all the information, I mean all the images. It's exactly like if you go to um, Ubuntu repository center, or if you want a literal meaning is, for example, you want a date of birth certificate, or permission to build a construction a home, or some permissions for municipality related. What you do, you just go to the municipality office and then apply for a license and you get it, right? Similarly, if you don't find any of the images in local repository or local registry, it will go to a centralized location. That centralized location is nothing but a Docker Docker Hub. The Docker Hub is nothing but this one, hub.docker.com. This is where you can just find any of the images. For example, Nginx or Ubuntu or Java or JDK. Whatever the most of the images that you can find here. Okay, that now let's come to the point here. That image is nothing but a layer. So layers, it's a combination of the layers. Each layers is consist of the functionality of the tool. For example, Ubuntu, a tool you are using, right? Why you are using Ubuntu? Ubuntu is nothing but the OS of a Linux, and then you can directly play around all the Linux tools, right? Similarly, the Ubuntu image is also having a layers in it. By using these layers, they are compressing with the one name called Ubuntu image name, and they are pulling it and they are using as it is directly, so they don't require any of the things. If you want a proper definition, right, what exactly that you can do is, you just simply, it consists of a multiple layers, and then it will have the similar functionality like exact tool. Okay, and one more thing is the container. Now we may talk about container also here, meaning with one image. For example, you just pull an image. What is an operation called Docker pull? What does it do is, it will just pull the image from the Docker hub. Okay. Now, next thing is, once you have an image in your place, you would create or you would start. How do you use this image? You would start this image. That start image, once you started, there is something will be pop up that is nothing but a container. In a simple terms, the running instance of an image is called the container, Docker container. Meaning, for example, here, there is a Docker image here. You just pulled called Ubuntu. Okay, this is a Ubuntu image. What you do is, you start this image. You have pulled it. You have to start this image, or the way, once you started, there is a something will be pop up. There will be something will be running here, right? That is nothing but a container. Okay, right? This is a container. From the same image, you can start another container. You can start how many containers that you want. Simply, if you want, the running instance of an image is called a container. And once you start a container, it will exactly work like a image only. Exactly not image. It will work like exact tool only. There won't be any difference. Okay. How do you start a image? You would use a command called docker run. Docker run Ubuntu. So it will just run it here. Let me show you that. Docker run Ubuntu. Okay, it has run. If we want to see how many containers are running, right? Docker PS, meaning what are the processes of Docker? There is nothing has come here. Okay, if we want to see the previous history of the Docker process, see, it is clearly saying exited, because the way that you run this Ubuntu image is not the correct one. That's why it is exited this process. How do you run it? You have to give something like this, because you have to mention this bash. Let's check this. Docker PS. And this is also exited here 9 seconds ago. let's see how do we need to run a Docker base image of Ubuntu. Docker run Ubuntu image here. So basically what you do is you would be providing a Docker pull, and then just directly you have to specify the complete path instead of a bash here, right? /bin/bash. Now let's check. Nothing. Again, it's been failed here. See why it is. I mean, let's talk about. I mean, let's analyze the examples also here. The commands that we have tried here. Let's understand the command first. Then we will use them. Okay. Docker run to create a container or to start a Docker image. Next, Docker PS to see process of a Docker images. Docker PS -a to see all the processes of a Docker images. All the means exited plus running. Docker PS only works running processes. Exited or killed processes. Not like killed. I mean, it's basically it has terminated on its own. So PS just will tell you the existing running process. PS-a will tell you the all the processes. Next, another command is Docker images. What does it do is it will just show you the list of images. Okay, this is one thing. Now, what you need to understand from this is if you want to run or if you want to create a container, this is the command. There are multiple ways of, I mean, the way is only Docker run command only, but we have to know how we have to run this Ubuntu image. It is expecting Ubuntu image required some bash, I mean, some terminal, I mean, which is nothing but a what program that you want to run. /bin/bash. This is how you require a provide an argument to Ubuntu image in order to run this. Okay. For example, there is an image called run nginx. If you want to run this nginx image, you have to export the ports, then only it will work. bin/bash. If you want to run a Postgres image, which is nothing but a database image, that required another parameter like port number 5432:5432:. It required a volume /.:. I mean, in the current directory, use this. In this one, var/data/ I mean, var/mysql, no, Postgres SQL/data something. I mean, how do we know? We have to go through the documentation of this image publisher and then find out what parameters that we need to provide in order to run their own image. We have seen 3 types of images just now to find out. Ubuntu image required some kind of a program which need to be run. This nginx required a port and a program. This Postgres DB image required a port number, volume, and of course there is a one thing called Postgres username, and username equal to tester, and pg DB password. 1 2 3 4 5 6 something. So this in order to run a Postgres image, or in order to create a container from an image of a Postgres DB, you require to pass all these parameters. So this is an important note point here. Okay. So you just need to remember. We will try a lot of things. Okay. Why? Because right, if you know how to run this image, you are almost been done. I mean, that is main part of it. Yeah. In some of the interview questions, right, how they do give a assignment is they'll give you an image and they'll ask you to find out how to run this image, or they will ask you to make this application running smoothly. What they do is simply, let me put it this way. They'll give you an image and they'll ask you to find out what is inside image. They have deployed some web application and they expose some APIs. They'll ask you to spin up this image, I mean, spin up a containers from this image, and then ask you what is an output from that. And you would ending up, I mean, you have to find out what this image required, like port number, does it require port number, volume, or network, or any other parameter it has been requiring, or what kind of data it has been requiring. Once you start running, first what you do in that particular situation, right, what you do is just, for example, they have given a Ubuntu image only here. For example, they have given a Docker Ubuntu image only. So you will try to run it, and then you see it is successfully work. If it is successfully work, first you have to find out that is in the process list. What is the command to see the process list? PS. Okay, nothing is running. If I want to see running and exited processes, PS-A. If you just give, it will give you the last history also, 7 minutes ago, last 5 days ago, 6 days ago. It will give you all the things. Recent one is 18 seconds ago. It has been failed. See, this Ubuntu image is required a command called bin bash. Ubuntu bin bash. Run. I want to go inside a container directly. So this is the one thing. Meaning, if you see -it, what I've just provided is, let me put it this way. You have a Ubuntu image, and then you ran, and one container is started. If you want to log in inside of this container, you have to do one thing called interactive mode. You have to start this in an interactive mode. In order to go with the interactive mode, while starting, either two ways you can do the interactive mode. One is while starting the container itself, you can go to the interactive mode by using a docker run -it. Another is you start in a background, then you go to the login to the container again. There are two ways here. One is while starting container itself, it will be going inside a container itself. See, you are just inside a container here. Now, if you see Docker PS, it will show you the list of the things. Let me show you here. I'm logging in another terminal. Docker PS. See, it has been showing from last 1 minute ago, it was up. And this is a process ID. If you give a -a, all are been killed. All are been killed. One has been up for a minute ago, because we are inside a container. This is one way of doing it. Now I'm just exiting from the container. What will happen is, meaning this container got killed. Okay. Now what I'm going to do is, I'm going to run in a background mode, same container. Instead of -it, what I do is -d. It has been started a container. Now what does it happen is, It just created a container and it did not attach the console to your terminal, which is nothing but a you run in the background. If we want to, now let's check whether this has been really started or not here. You see here Docker PSA. Previously, King Gates was running. We stopped when once we exited that container, it automatically stops. Okay. Even this also, the one which we just created also got exited here. Let's see why. See, it is immediately exited. That is requiring some other parameters. Let's see how to run a Docker based image. Yeah, simple. It is going inside. Now it is showing me the list of the stuff here, but why it has been exiting? 7 seconds it was updated and fine. Okay, we will see. We will see, guys. But I hope this is fine for today. And for another 2 to 3 days or 2 to 3 classes, we will be our entire worker or our entire work will be within this Docker containers, images, editing these containers, saving it, committing it, running the containers, communicating the database container and an application container, how to modify a container, how to build an image, how to build an image from the image, how to create a container, how to change the changes, how to do the changes in the image itself, how to rebuild it, so how to upgrade the containers, all around will be presented. And of course, the volumes and networks also we will be dealing. What we do is we will learn all these concepts like images, creation, volume, compose through use case based. Okay, we'll talk about a use case and then we'll learn this concept because that's how you would be doing. If we learn as a concept inside a Docker, right, we will just like a remembering, but we won't remember it. We will just learning it. We don't get a good remembered if we learn as a concept. But if we learn with the use case based, right, it will be easily rememberable. Okay, right? So another 2 to 3 days we will be within this only here. We just talked about the images and containers, right? But of course, there is a something we have to talk about this. There are another 2 to 3 days or 2 classes minimum. We will be talking about the Docker. And please make sure you do have an installation of a Docker in your mission. Okay. Any questions, guys? This is it from me today about the Docker. Let's continue for tomorrow. Please let me know if you have any questions.